Hi, this is Workman Knight. In this video, I'll talk about sine and cosine, unit circle, and chain rule tricks. Let's get started. So I have a unit circle right here. Let me fill in the blanks. Okay, so the little trick right here is that anytime you do derivative of a cosine or sine function, you move clockwise within the circle. Anytime you integrate a sine and cosine function, you move counterclockwise within the circle. Let's go over an example. Derivatives. Let's say I had cosine of x. Derivative of that would be sine of x. Negative sine of x. Sorry. Derivative of sine of x would be cosine of x. Whenever I derive sine of x, I'm going clockwise. Now, whenever I derive cosine of x, I'm going clockwise again from here to here. So say derivative of negative cosine x, I get positive sine x. And lastly, let's say I do derivative of negative sine x. That'll just be negative cosine x. Seems pretty straightforward enough. Now, your integrals. Let's say I did integral of cosine x dx. I would get sine of x. Going back to unit circle for reference. Now from here counterclockwise. See. Same thing. Integral of sine dx is just cosine of x plus c negative cosine of x. And for the rest, just follow unit circle. So I go counterclockwise like this. Alright. Now for chain rule. So for chain rule, let's say I had this for instance. Sine of 5x. Sorry, let me fix this 5. 5x derivative. So for chain rule, the rule goes like this. F of g of x derivative is equal to f prime of g of x times g prime of x. So essentially, I take the derivative of the outer function with the inner function as its parameter, then I multiply it by the derivative of the inner function. In this case, the inner function is 5x. And outer function is sine of x. So let's do that step right here. So the derivative of sine of x, density in circle would just be cosine of x. So that would just be cosine of, still use the inner parameter, 5x. Sorry. Times derivative of 5x, which is just equal to 5. So the answer is just 5 cosine of 5x. Okay. Now, every student should always use the chain rule, right? But there's a shortcut to this. Let me erase this real quick. So, it's a little trick I always use. Let's have sine of kx derivative, right? K is just a constant. I just do cosine of kx times k. In this case, k k is 5. So I apply the same rule here. It's just going to be 5 cosine of 5x. So that's just one shortcut I always use. And the same thing applies for cosine. Cosine of kx derivative is just equal to negative sine of kx. Alright, now let's look at chain rule with intervals. So let's say I had integral a sine of 3x dx. Normally, we would use u sub. So in this case, I set u equal to 3x du equal to 3 dx. I then solve for dx. So du over 3 is equal to dx. So then I substitute. I don't integrate, but substitute. That should be sine of u du over 3. Just substitution here, substitution here. If I then integrate, I then get cosine of u with a third outside as a constant. Then I substitute u back in. And I should get cosine of 3x. So that's the typical way to do it. However, once again, there's a shortcut. So let me erase this real quick. So, like with derivatives, there is a rule you could use for chain rule related to sine and cosine. So let's have integral of sine of kx dx. What I could do is integrate normally, so that would be cosine of kx. Now, the only difference is that I use the reciprocal of the constant. So 1 over k cosine of kx plus c. I never forgot the c before here earlier, but I include plus c. So in this case, it would just be 1/3 cosine 3x plus c. Alright, now here are some practice problems for you to do. I'll give you time to pause and do those problems. Alright, here are the answers. Let me know if I made a mistake or have any more questions. Okay, thanks for watching. Hit the like, subscribe button, and I'll post more content in the future. Thank you.